This is SIG scheduling, the Kubernetes SIG scheduling group. The date today is August 17th, 2017. And today, Avesh wanted to give a quick demo of rescheduling. Why don't you go ahead and demo, Avesh?
Yeah, thanks, Tim. I'll share my screen now. Is my screen visible?
Yes.
Okay. So just starting demo, I prepared a few slides to set some context for demo. Here I'm going to talk about rescheduler, and it's based on the design proposal that I have already sent to SIG scheduling working group. And just like this rescheduler that I'm going to demo can be executed as standalone utility outside a kube cluster and also as a pod in a job, and it has a frequency interval so that this scheduler can be run as needed, for example every 1 hour, every 2 hours. Also there are knobs like to avoid momentary changes like high or low spikes, so that the rescheduler is not triggered as soon as something happens. If something happens for some longer time, then maybe it's better to trigger rescheduler, because rescheduler by design is disruptive, and we want to reduce disruptions as less as possible. So in current, like I have implemented two strategies. First strategy is rescheduler checks whenever there are duplicate or more than one pods associated with the service, with the same service on the same node. It evicts those pods. Generally, like the assumption here is that it's not needed for high availability to have pods associated with the same service on same node, more than one pods associated with the same service on the same node. So this is one strategy. Another strategies I have implemented, it's based on node utilization. Actually, node utilization can be in different scenarios. Let's say whenever new node is added, then node mostly would have low utilization because it's newly added nodes. And then there might be existing nodes which might go underutilized for whatever reason, pods are terminated from them. And there might be existing nodes, those are coming back after maintenance. So in this strategy, it really doesn't make any difference whether it's a new node or existing node. As far as the node is with low utilization, this strategy is triggered. And there are two configurable thresholds, like usage thresholds and target thresholds. And these thresholds are based on CPU memory and pods percentage. And then there are number of node thresholds also. So for example, let's say you have very big large cluster, 100, 200, 300 nodes, and there is only one node with low utilization. Maybe for some it doesn't make sense to run rescheduler. So you could really set number of nodes threshold, so that whenever number of low utilized nodes are above, then only rescheduler is triggered. I have also prepared a graph to explain this, because this is a more complicated strategy than the first one, just to show like how this strategy work. I'm sorry, this is like hand-drawn diagram I have just created. So basically, if you see on this x-axis, there are node IDs. Basically, you could just imagine, and on y-axis, like one of the uses metrics like CPU, memory, or pods. In reality, this is a 3-dimensional graph, but just for simplicity, I have presented just one dimension so that it's easier to understand. So here you can see like there are two thresholds, like target threshold that is in between, and there is some low threshold, usage threshold that is used to compute how many nodes are underutilized. And then the target threshold is used to compute how many nodes are above target utilization. And as I said, this target and these threshold are configurable, so that these two can be tuned as needed. So basically, idea here is like for this low utilized nodes, this much capacity, we could move from the nodes from the nodes those are above target utilization. So basically, this much capacity we could move. This capacity could be higher than could be larger than this. So, but we don't move anything more than this, so that no node goes above target utilization. Also, like it depends on several other factors also that I'll talk about. But this is how basically this strategy works.
So you never mentioned disruption budget anywhere in your conversation piece.
Yeah.
Just wanted to make sure that those are all adhered to.
Yeah. I'll talk about this. I'm going to talk about eviction. Yeah, just a second. Oh, I'm sorry. So this is how this strategy works and how this eviction strategy work. Because first of all, I'm using eviction sub-resource, and eviction sub-resource by default takes care of pod disruption budget. So as far as like whenever any strategy tries to evict a pod, it gets error if pod disruption budget is violated, and then we ignore that pod and we don't continue with that pod. So that's how like indirectly that is taken care of by using eviction sub-resource. And this like there are some non-removable pods, basically like daemon sets, pods with local storage, critical pods, mirror pods, and pods in system namespace that are yet to do. These pods are never removed. And whenever there are more pods to be removed, best effort pods are always removed before bus-stable and guaranteed pods. So now I'll start my demo. I'll show both strategies, how they work. Also, like I have just prepared this demo only in 2-node cluster. Initially, I wanted to use some simulator like they have in autoscaler, but somehow like I didn't get enough time to do that. So I'm showing that only in 2-node cluster, and I'm hopeful that it should give some idea like how it's really working. So here, if you see, like I have 2-node cluster, one node is ready and another is not ready. So it's like I just want to I want to show you, like first I will schedule pods on the ready nodes, and then I'll run a scheduler what it does when the other node comes back. So as I said, like first I'm going to show strategy 1 where that creates duplicate nodes associated with some services. Also, like I'm not creating services here, I'm just creating replication controllers with 2 replicas. How to minimize this? Okay. So if you see, I have created these 8 pods, and they are basically 4 application controller, and there are 2 pods associated. Basically, they are simulating that these 8 pods are associated with 4 services, and they are on the same node. And now I'll start another node here. So basically, it simulates like new node is coming back. Or maybe there is already existing underutilized node, or some node is coming after maintenance. As such, there is no difference if we just see from low utilization perspective. So now both nodes are ready. But if you see, all the nodes are only on, all the pods are only on one node. Now in this window, I'll run a scheduler. Also, like this schedule runs both strategies one by one. But right now, because no node is underutilized based on, I should show you later about that. But right now, it's basically only strategy 1 will be run. So you see, like it did not process, it did not do anything with the node 120 because that node was a new node, and then it processed node 61. And if you see here in this window, like I don't know how to minimize this. Yeah, in this window you see all those 4 duplicated nodes are evicted, and now those nodes are moved to 120. So so now you see 4 nodes are 4 pods are on new node 120, and 4 pods are on already existing node 61. So this is like just simple thing. Now I show you like the second strategy, like low utilization based strategy. First, I'll just delete this all the existing pod to just show that. So they are terminating right now. Once they are terminated, and I'll show you like how the second strategy works. It might take some time, a few seconds.
It ripped through all of the different controllers on the node.
Yeah. Yeah, right.
Instead of, I know that you said there was a threshold. It'd be nice. There might be an option that you might want to consider about the amount of churn per node.
Yeah.
That will affect overall load average.
Yeah. I'm going to show you that strategy next, because as I said, this strategy only takes care of removing duplicates associated with some surveys. So that's why I did not take about that load. I'll show you another strategy right now that will take care of that load. Like I think you're talking about. Just a second. Again, what I'll do, I'll stop this node so that it simulates that this node has gone down or gone for maintenance, on for whatever. Just a second, like before, yeah. So before this node becomes not ready, I'll show you the policy here. So if you see this, because the first strategy I did not have any parameters. So, but for this strategy, low node utilization, like I have at least I told you, like there are 2 thresholds, threshold 1 and target threshold 2. So basically the first threshold, so like all these thresholds are in percentage. Like when the CPU uses are less than 20%, memory is less than 20%, and ports are 20%, that means that node is underutilized. If all these metrics, CPU, memory, and ports are under 20. I mean, as I said, you could tune the way you want, but for example, I'm showing this. And this is target utilization. Target utilization is like where we want to have our nodes at this threshold, like 50%.
But this is the capacity values, right? This is what a pod has specified that it wants to use. This isn't necessarily the load average.
This is like let's say if you have maximum number of pods, let's say 20. This means pods, it's 50%. Like we want to keep only 10 pods on each node. That is our target. Does that make sense?
Your threshold that you're specifying and your target threshold.
Yeah.
That value for your CPU and memory.
Yeah.
That percentage value that you're using there.
Yeah.
That what internal parameter are you using that to gauge against?
Yeah. Pod request.
So it's the actual request value, not necessarily the load average.
Yeah, because the reason is, as I said, like right now, either I think we'll have to integrate it with like, for example, Prometheus and that kind of thing. Because otherwise, to get the right correct load average, the only value we have pod request values. I think scheduler only uses the same thing for calculation. But I think that is part of future work. But right now, you are right. That's why like we have 3 parameters: CPU, memory, and ports. So even though CPU and memory are based on only request, because we are taking care of ports also. So at least it's not. I mean, it might compensate for that for some up to some level. So this is not the real load average. Yeah. This is just like what we get from the pod requests. but this is for every node for all the pods on that nodes. But the only thing like we don't know here, like first of all, like best effort pods, those are not specifying. So that is one thing. And then this is not the real load averages. But as I said, like because we are taking care of number of pods, so in some way it might help. So I mean, right now we have that, but as I said, as future work we want to consider load average. But I think for initial thing this might be good enough, and I'll show you like I'll just run that. So what I'll do now, again I'll create some pods. Like I'm going to create 12 pods. Those are like stable and guaranteed pods, and I'm going to create 4 pods. Those are only best effort pods. So I think there are only 4 pods. Those are starting with B. Those are like best effort pods. All other pods are guaranteed and bustable pods. And those are like created by replication controller with one replica. But I think that is not that important in this strategy. So what I'll do, I'll again run a rescheduler. Right now what I'm doing, I'm not starting another node. There is just one node, and I'll show you that even if I run a rescheduler, it won't do anything because there is just one node. Or basically what it's doing, it's simulating all the nodes are above target utilization. Let's say you have 100 nodes and all are above 50%. That means there is nothing like rescheduler should do unless you again tune your thresholds. So all are running now, and now I'll run rescheduler. See, no node, it says no node is underutilized because there is only one node, and here it says how much is the utilization on that node. Like there are 80% pod because the maximum pod I have number of pod I have set 20. So because there are 16 pods, it says 80, and CPU is like 37.5 and memory is only 10. But because as far as one metric is above target utilization, that means that node is above target utilization. Now what I'll do, I'll restart that another node again. Let's see it becomes ready, because reschedule does not consider any node that is not ready. So once it becomes ready, I'll run this again. So now this node is ready, and we will see like what happens. Once I'll show you like what happens, like whatever default thresholds I have, then I tune those thresholds a little bit to see like how that impacts. So now, so if you see, first it evicted best effort pods, and then it evicted other 2 pods. Because as I said, like there are 50%, only 50% pods could be there. So it stopped at 50% because 50% means 10 pods, and other pods it moved to 100, the other node that is .120. So if you see here, they are still terminating like 6 pods are on node 120 and 10 pods are on so you see here, so there are only like 6 pods on a 120 and 61 pods on 10 pods are not 61. Right now, without tuning your strategy, if you just run a scheduler, it won't do anything, because again it says no node is underutilized, because now both nodes are like above. No node is underutilized. I mean, there is no node like underutilized, so it's not going to do anything. Now what I'll do, like I'll just tweak my policy. What I'll do, I'll make all these 40-40. Since I have made that 40, this is the first node, it has become underutilized because the power percentage is 30, and even those are also CPU and memory are also under 40. So now what I'll do, I'll run this again. So you see right now only 2 pods are evicted. Also, like even the previous tuning was also very good, because if we don't want to create as many disruption, I mean, because we want to create as less disruption as possible. But if you see that tuning was not that balanced, because one node had 10 pods and one node had 6 pods, but that was also good enough. But if we really wanted to have some more balance, we could, I mean, as far as these two thresholds are closer, I think the nodes will be more balanced. But it's not like we always want to do that. We might not want to do that to avoid unnecessary disruptions. So now if you see, because those 2 pods were evicted, now both nodes have like 10 pods, oh sorry, 8 pods. So I think that's all I have. If you have any questions. But I mean, as I said, like right now it's based on pods request values and not the real load.
So I don't know if other folks have other questions. Avesh, do you have a link that you want me to put inside the notes with regards to taking a look at the code at all, or if people want to contribute?
Yeah, it's on my under my account on GIT Hub in rescheduler. And as I said, like although there are not many folks here, I wanted to go for Cube incubator repo so that more people could contribute. As I said, this is a initial version, and we really want to like go forward with, because there are so many other things we could implement. But definitely I can send you a link to a SIG scheduling group also.
All right.
If you want here, I can post. Hello.
Yes.
Hey, this is Bobby. Sorry, I arrived a bit late, so I had back-to-back meetings, so I arrived a bit late. Maybe my question is already answered, but I was wondering if what you described can be implemented as sort of like different policies in the current autoscaler, or is it a completely different concept?
I would say like I think autoscaler has different goals and rescheduler has different goals. I mean, definitely from implementation point of view, you could implement anything anywhere, but conceptually those are like very different concepts as I understand. So I mean, I'm not sure like we would really want to combine those two. But one thing, like as I said, definitely rescheduler could be integrated with autoscaler, because whenever autoscaler adds new node, it can help rescheduler to know when it should trigger. For example, let's say whenever autoscaler adds a new node, it could send a signal to rescheduler so that rescheduler know new node has been added, and then it could trigger a strategy so that the new node could get some pods and it's not underutilized. So definitely like integration could be done, but I'm not sure like the policies or strategies I have implemented in rescheduler, we want to implement that as part of autoscaler. I mean, theoretically, from implementation point of view, anything could be done, but I'm not sure whether we want to do that or not.
Well, the reason that I asked this question is that looks like rescheduler, the rescheduler that you proposed works closely with the fact that new nodes are added and removed to the cluster, and it acts mostly based on, at least one of the scenarios that you just described. It looks like it acts on that event, and that event is today controlled by autoscaler. So that's why I felt like maybe this should be a part of autoscaler, or works based on some sort of like signal from autoscaler or something of that sort.
But as you said, like this, that is just one scenario. I mean, adding a new node or I mean, that is just one scenario. Even if you don't add any new node, and if you have your existing cluster, and still you might have nodes underutilized, because some nodes might be terminated from those nodes, and in that you could rescheduler without autoscaler. So
sure, but what's the benefit of basically after some of these nodes are underutilized, what's the benefit of
Balancing, have a more balanced cluster, like by tuning the thresholds I have. I mean,
Sure. Yeah, that's certainly a good point. But I guess it'll be more useful if, in those cases, autoscaler could remove nodes from the cluster to reduce the cost, as opposed to like.
yeah, as you said, I agree with you completely. But what I'm saying, there are other scenarios where, like, even if you don't use autoscaler, it could be used. In fact, I have seen some users asking about that. For example, in one of the clusters that one user was maintaining, what happened? Because of some reason, some nodes went down, and all the pods moved from the nodes which were down to other nodes. And when the nodes came up, that user was really looking for how to move those pods, those already moved to other nodes, back to the previous nodes. So
Right.
in this scenario, there is no autoscaler, but still, like, rescheduler might help by just going through those nodes and then having pods move to the previous nodes which came back.
That's a good point. Yes, that's right.
There's definitely a state space for expressive policies because people will want to do different things based upon where they're running.
Yeah.
For example, like if you're in a heterogeneous environment, you might want to tune based on load average.
Yeah, exactly.
So it gets very NP hard in this space. So having the ability to have expressive policies becomes pretty important because everyone's policy is going to be different.
Yeah. In fact, current policy I have designed, I would say it's very flexible, and it like new stuff could be added as easily as possible. I mean, I think that's possible, really. Yeah.
Right. Well, don't get me wrong. I was not questioning whether having something like a rescheduler is useful or not. Certainly, this is useful. But my question was mostly like around the idea of whether we should sort of like integrate it into autoscaler or have it as a separate component.
Yeah, I think what we discussed previously, or at least what I have seen, I think the idea was to integrate it with autoscaler, but not to make it part of autoscaler. I think that we have already discussed make it integrated with autoscaler. So, but it was always good to have as a separate component because there are so many use cases. I think autoscaler is not worried about them, and where rescheduler could help.
Sure.
I agree.
Thank you.
Yeah.
Are there any more questions for Avesh? Going once, twice, 3 times. All right, thanks, Avesh. If you have more details, if you want to add them to the meeting notes, I'll put a meeting notes link in the chat window. That would be useful.
Yeah.
Are there any more group topics that folks wanted to discuss today? I know several folks are late. I did have a question with regards to, now that you're here, Bobby, what the status was of priority and preemption, because that affects a whole bunch of things. So I was wondering if you could give a quick TLDR of where it's at. I've been backlogged on a lot of my SIG scheduling responsibilities, so I wanted to.
Yeah. So a quick update on priority and preemption is that priority API and also the admission controller and everything is already meshed. Part of the preemption work is already submitted for reviews. I ran into an issue with respect to, well, I don't know how many people are familiar with this, like predicate meta pre-computation and all. So what we do in that area of the scheduler is that we sometimes, for some of the predicates, we pre-compute some information before running the predicate for all the pods in the system, so that we can run those predicates faster. And that part was not really built for preemption or sort of like having like something like a dry run that preemption work needs. So I had to spend quite a bit of time to prepare all of those. I've already sent those PRs as well. I am kind of hopeful and optimistic that I can send all the PRs for preemption work before 1.8 deadline. Whether we can get all of those merged before the deadline or not is a question I cannot really answer. It depends on how fast the reviews will go.
Okay, that's a good synopsis. I saw Connor put something else inside of the agenda.
Yeah, I just dropped in some links just as a heads up for this group. There's a bug that was filed because of some kind of weird handling in the scheduler for how namespaced resources are handled. I guess it's kind of it's a combination between API validation and the scheduler. The short story is that namespaced resources, if they're included as part of a container resource request, would pass validation and get ignored by the scheduler. And so your pod could be scheduled even though your container contains a request for a non-existent resource, which I thought, I brought it up to David, and he was kind of surprised by the behavior. So the fix is kind of in two pieces, and both of those PRs are linked there. The first one has been merged already, which is to handle namespaced resources outside of the Kubenetes.io domain as opaque integer resources that do not allow overcommit. And it also special cases the OIR, the legacy OIR prefix inside the Kubenetes.io domain. And the second one is still being discussed. Clayton's on the call. He had some comments about making sure that we're not breaking anybody, but that one basically requires every resource used in a container resource request to be a known name. So you can't just do like Kubernetes.io/mycrazything and have the API server and the scheduler just ignore it. So yeah, if you are aware of anything that those changes could affect, please add comments, and reviews are appreciated.
All right. Are there any more issues that we wanted to discuss today? Going once, twice, 3 times? Okay. Well, thanks everybody. And just a heads up that for other SIGs that there are proposed release notes that people are requesting. So if you have a feature like that you wanted to PSA as part of the release notes process for the core, I think the rescheduler would live outside the core. So like priority and preemption is one of those things. Please talk with Jace about getting an updated section for the release notes beforehand. It's always possible for us to pull later on, but they're trying to do things ahead of time this release. I think that's all I have then. Unless there's any last comments.
Mm-hmm. Okay, I will send those release notes to Jess.
All right, thanks everybody.
And thank you, Avish, again.
Yeah, thank you everyone.